So we can start now. Hello everyone, welcome to Talk Series 4.7 on load requirements for eCooking. To start the session, I would like to invite Mr. Krishna Kumar Sinha. Mr. Sinha holds a background in mechanical engineering with an MTech in production engineering. He served the Ministry of Commerce and Industry for 35 years in various capacities, including roles in automobile industry desk, export promotion cell. Over the last 16 years, he led FDI promotion for Americas and CIS countries, gaining extensive experience in FDI policy, FIBB case analysis, and manufacturing and industrial policy. Currently, Mr. Sinha is an advisor for Finovista. Welcome, sir, and I would we can start with a
Thank you, Satyam,
presentation. I will
for
just
a
share my
very
screen.
generous introduction. Thank you, Satyam, once again. And welcome to the talk session 7 of the phase 4 of the talk series. The topic today, as you all know, is the managing the load requirement for electric cooking. This talk series, Satyam, would you like to show that our small presentation to give an introduction?
Yes, sir, I am just sharing my screen. Let me know if this is visible.
Yeah, it is there. I can see.
Yeah.
So the first slide is about the topic of the series, and it says that this is the 7th session of the 4th phase of the talk series. It began about three years back, and we have already completed the 3 phases, each phase having 12 sessions. So we have completed 12 into 3, 36 in the first 3 phases, and then in this phase we are into 7th session now. So it's a quite popular, has been next slide, Satyam, please. Okay. It's a quite popular, as I said, that so many people have got 1,000, more than 2,000 people are registered for this, have registered their name for participation in this. And it's not just for India, but it's a global platform for sharing ideas and experiences by different experts. And today, as you can see, it is being managed by Finovista. The Finovista is actually the in-country partner of Modern Energy Cooking Services Program, which you can see here in the slide. A very small description that it's about 8-year research program funded by UK Aid, FCDO, and led by Loughborough University of UK. This program researches the socio-economic realities of a transition from polluting fuels to a range of modern fuels. While the research covers several clean fuels, it may be biogas or even other gas, which are more environment friendly. And also, but the overall evidence coming out of the research work carried out so far is pointing to the viability, cost effectiveness, and user satisfaction that energy efficient electric cooking devices provide. So the program works in close collaboration with NGOs, governments, the private sector, academia, policy representatives, and communities across 16 countries in Africa, in Asia. And it is working to accelerate the shift from biomass to genuinely clean cooking in India. The program was launched in early 2020 through Finovista as the Indian partner, as I said earlier, and works across the intersection of policy, finance, supply chain, and promotion of electric cooking to enable the transition to modern fuel for cooking. It is also supporting India's emergence as a leading manufacturer of clean cooking devices, both for the local market as well as for export or international market. And this is aligned to the Government of India's policy of Make in India and Atmanirbhar Bharat, as well as objective of Go Electric scheme launched by Ministry of Power, which promotes both electric cooking and electric vehicles. Second, next slide, please. I spoke earlier about the popularity of this talk series, and as I said, it is a global virtual platform that brings together the key stakeholders to initiate discussion on aspects that are critical to enabling the shift to modern energy-based solution for clean cooking. As I said, 12 session per phase, and we have completed the first three phases, and we have completed a six session so far in the phase four. So it's altogether 36 plus 6, 42, and we are into 43rd session today. And more than 2,691 global registration, more than 2,000 attended uh, this talk session so far, and I benefited from the information shared and clarification given during the session. Any more slide in this, Satyam?
Yes, sir.
Okay. Okay, yeah, that's a good, important information because we always plan a bit and in advance about the talk session. And we have already finalized the next session topic, which is will be talk session 4.8. Building community champions, train the trainers for self-help groups on e-cooking. And this is going to be aired, or it will be done on 22nd January 2026 at the usual time, and it would be virtual as is the practice. So that's all as far as presentation is concerned, I consider, Satyam. So so, I mean, just to, I would like you to brief about the current topic, which is managing the load requirement for electric cooking. It's a technical topic, and we are very excited about it because it's really important to implement a faster transition or mass adoption of electric cooking. And we all are well aware, and the evidences have proved that the electric cooking in developing and emerging countries, India or Kenya and other nations included, offers significant benefits for public health, gender equality, energy security, and climate mitigation. However, its large-scale adoption also poses challenges for, I mean, in different sectors. In the earlier talk sessions, we have discussed like utensil compatibility, which is a must for induction cook stoves, or the supply chain for the electric cooking devices. So we have covered this. Now, this in the today's session, we will be discussing about the challenges for electricity grids, which that are often constrained by limited generation capacity, sometimes by inadequate distribution network, distribution electricity network, and peak load stress. Managing grid load requirement is therefore central to enabling a reliable and affordable shift to electric cooking. It's due to the concentration of cooking energy demand, during peak hours, typically morning and evening, which coincides with the existing residential and commercial electricity peaks. So both combines to make it a tough job. That is why grid management is important here. And if we don't manage it, an unmanaged electric cooking loads can strain transformers, feeders, and substation, increasing the risk of outages. To address this, the first responsibility, of course, is the utilities, which need to adopt demand-side management strategies, including time of use tariffs, smart meters, and incentives for the user for off-peak cooking or pre-cooking. Moreover, efficient appliances such as induction cooker stoves, electric pressure cooker, and insulated cookware can significantly reduce energy consumption and peak demand. So the responsibility also lies with the manufacturer and also with the standards governing authority like Bureau of Indian Standard. And they are doing it in terms of star labeling and all those things. Now, decentralized and distributed energy resources also will play a critical role in easing grid pressure rooftop solar or like community solar system, mini grids, and also combined with the battery storage can supply a substantial share of cooking energy, particularly during peak time. In rural and peri-urban areas, hybrid system integrating grid power with solar like grid-connected rooftop plant and battery storage can reduce dependence on weak central grids while improving reliability. Thus, grid strengthening and planning are important. Utilities must there is a need of strong coordination between authorities looking after various aspects. For example, utilities must incorporate electric cooking demand into load forecasting, distribution network, upgrades, and all those things. And it is also essential to align infrastructure investment, appliance standards, consumer awareness, and also the integration of renewable energy into the grid. With proactive grid management, efficient technologies, and integrated planning, electric cooking can be scaled in a scenario as available as it is in developing countries without compromising grid stability while accelerating progress towards clean energy and development goals. Today, to discuss this, I have just mentioned some of the topics which might be covered by the experts. To discuss the topic, we are very lucky to have a number of experts who have kindly consented to participate in the discussion and share their knowledge and expertise and ideas for faster transition to electric cooking in India and other countries. So our first speaker of the session is, it is my proud privilege to introduce him. He is Dr. Nigel Scott, Director, Gamos Limited. Dr. Nigel is a founding collaborator with Loughborough University on MECS program. He has over 20 years of experience in research into energy in low-income communities. He leads on curating data from across MECS activities and provides technical input to both the design and analysis of data-based activities. He holds a PhD in electrical engineering from Imperial College London. So welcome and thank you, Dr. Nizam, for agreeing to address this session. And I would like to invite you for your presentation. Over to Dr. Nizam.
Thank you very much, Mr. Sinha, for that very kind introduction, and also for your very comprehensive overview of where we are with loads and the importance and significance of understanding sort of electric cooking loads as we look to the future. Let me just see if I can share. I had a few slides. Let me see if I can share my slides. Does that work?
It is visible.
It is. Okay. So although Mr. Sinha sort of talked about some of the difficulties encountered by the grid and networks on the Indian power system, I think India is in the impressive and enviable position of now having universal access. So the authorities are in the position of beginning to start planning for the future. And in the flyer for the talk, it talks a lot about the increasing demand that will be arising from air conditioning, ownership of air conditioning equipment, electric vehicles have been mentioned several times. So these are all the kind of things that are going to increase the electrical loads on the network. And cooking will be part of that. So India has a proven track record in transitioning to clean cooking at scale, particularly through the LPG program. But e-cooking is going to be an increasing part of that clean cooking mix, especially things like the Go Electric campaign that Mr. Sinha mentioned earlier. So it's important to integrate electric cooking and e-cooking loads into power system planning. So we need to understand a little bit more about e-cooking, if I can call it that, electric cooking loads. So this morning I wanted to very briefly share with you some research that we did looking at induction stoves from a few thousand customers, household customers across Africa. So this is an example of a load profile that we created using the data from these induction stoves. So these stoves were connected to the internet and reporting back to a central server every time the stove was turned on. The data gives us the start time for the cooking event, the duration for the cooking event, and the energy used in each cooking event for each customer every time it was used. So what I've done here is pick out one day, and I've aggregated. So from that information, you can calculate the sort of average power that's used in every minute of the day. And I've aggregated that across all the customers in that sample. And this is what an aggregated load profile might look like for one day. So clearly you can see a bit of a morning peak, and the maximum demand occurs in the evening. But clearly the load profile that you might get will be different every day. So we then tried to increase the scope of the data to look at a 3-month period. So this gives obviously a smoother profile. It smooths out a lot of those little jagged peaks. And also you can see a lunchtime peak emerging more clearly. So these are more average figures, and the blue bands represent the 5 and 95% confident intervals on those figures. We then looked at the diversification factor. So the diversification factor is defined as the theoretical maximum load, which is simply the total number of stoves in use multiplied by their power rating, divided by the maximum load that you can see here on the curve. So on this particular curve from Kenya, that maximum power is 300, but we had nearly 1,500 units in the reporting data. So that gave us a diversification factor of around 10. And that diversification factor is really important because it's representing the fact that not everyone is cooking at the same time, but also the devices are not on full power the whole time. Obviously, you turn it up maybe for the full power for a few minutes until your pan boils, and then turn it down for the remainder of the cooking period. So this diversification factor, I think, is a really key feature that that's not really been published before. So what influences these diversification factors? So on the slide here, I've just presented the different shapes of load profiles that we've got. So top right is the work we did in Africa, and these have been normalized down to 1,000 units, so they represent the same numbers of customers, but the shape of the profile is slightly different. So you can see Kenya and Tanzania, the peaks appear at the evening meal, which is quite late into the evening. You can see the Kenya peak is much higher. In Ghana, there's an absence of the lunchtime midday meal kind of peak. So these illustrate the differences in cooking culture, and that depends on obviously country and also maybe market segment, rural, urban. So if you look at the charts below, I've pulled out, again, these are non-dimensional charts, but I just wanted to illustrate the fact that you can get different load profile shapes in different places. So these are a couple of Asian countries, and they show the peak which tends to occur at the midday meal rather than the evening meal. The dotted line represents urban customers, so that shows there are differences also urban, rural. Coming back to the three curves at the top, the main factor that really influences the peak factor is this intensity of use. So how much are people using their electric cooking device? Obviously, if they hardly use it at all, the diversification factor is going to be large. So you can see here, Kenya usage was slightly higher at 1.7 kilowatt hours a day than it was in the other countries. Therefore, the diversification factor is slightly lower there than it was in the others. And the key thing there is that as more of the menu gets transitioned to electric cooking, we can expect those diversification factors to fall. We're talking about integrating electric cooking into planning. So modeling will be important for that. This is a stream of work that the MECS program is still currently working on. And so far, we've shown that you can represent a 24-hour load profile using these three Gaussian curves. So obviously corresponding roughly to each of the 3 meals in the day. In order to draw those curves, you need to know what the peak time of day is. You need to know the distribution of the cooking times around that mean. And then you need to know the amplitude, so how high is the peak. So you can see that illustrated in these three curves that have been combined together to give the red line, which very closely matches the actual data. The point of that is that much of that data to generate these curves can actually be gleaned from household surveys, which are obviously much cheaper and quicker than actually having to deploy a load of units as we did for our original research. So with household surveys, you can simply ask people times of day, when do they cook their meals? You can ask them also what kind of equipment they have, and you can ask them what fuels they use to cook different parts of the menu. That gives you an estimate of the menu penetration of electric cooking. So that gives us quite a lot of information that can be used to estimate these curves. So this is going to be really helpful for planning. I want to just finish just summing up a little bit. So we know, as has been said in the introduction, that residential electrical loads are going to be increasing. And we need to be including electric cooking in that thinking. And I've just copied a chart here from a recent paper by some Indian people looking at a modern Indian household. So that includes air conditioning and electric vehicles. So this is used as a sort of baseline for projecting what demands are going to look like in the future. So what you can see there is the time of day that Mr. Sinha talked about earlier. In this projection, they're talking about 2 peaks, early morning and in the evening. And from the work we've got, you can see that if the lunchtime peak occurs around midday, that fits very nicely into the trough. But these are the kind of things that need to be considered in the planning. And I said, I've not even talked about demand side management. So at that point, I'm going to draw to a close, but I think this is quite a nice little introduction to our other speakers. I'm really looking forward to hearing from who are involved with how to manage the network, what can be done with energy efficiency, and what smart technologies can lend to help overcome the problems. So with that, I'll say thank you very much, and that be I'll hand over to you, Mr. Sinha. Thank you.
I think I'm stepping in at this
Thank you,
point, Nigel.
Dr. Scott, for a very, very comprehensive presentation. And I must say that we are going deep into technical waters of electric cooking with your presentation. We have really, I mean, you went into the experience you have and the data you have collected from Uganda, Kenya, or even Bangladesh, I saw some places. These are going to be very, very strategic. I mean, for strategic planning of for the utilities, in particular, the diversification factor, which you mentioned about it. and other peak load time and all those things. So thank you very much once again, Dr. Scott, for your very, very insight on this subject. And as we move forward, I think it's time to hand over the sessions to Dr. Nick Rousseau, who's International Liaison Manager of MECS program for India. And as a very brief introduction of Nick, has over 20 years of experience of working in UK government. His final role was Head of International Innovation Strategy at the Department of Business, Innovation and Skills. Dr. Nick led the innovation strand of the Newton program also, and government-to-government policy dialogues. His consultancy, Unconventional Connections, focuses on innovation, collaboration, including work funded by DFID on harnessing the UK's strength in clean energy technology to increase access to clean energy in Africa and Southeast Asia. Nick has a personal interest in sustainable solution to local and global food-related challenges. In 2015, he set up the Woven Network, UK-based network for those working on insect protein, an interesting subject indeed. Dr. Nick holds BA, that is Bachelor of Arts, Master in Science, and PhD degree in Psychology from the Universities of Cambridge, Loughborough, and Sheffield, with a focus on psychology and user-centered system design. Within the MECS project, Nick is one of the international liaison managers for India, and we have been highly benefited by his presence here. So over to Dr. Nick, and welcome to the session.
Thank you, Mr. Sinha. I hope you can all hear me okay. Great to have this introduction of and setting the scene. As Nigel and Mr. Sinha have acknowledged, this is a complex area with a lot of technical detail, and we're going to get as far as we can in the remaining time. But I'm sure it'll be just the start of well, not the start. It'll be a key element of an ongoing dialogue with the electricity sector across our many countries. And I'm pleased to say that this is, as an event, a milestone for us, because it has been jointly organised by Finovista and Gamos East Africa. And so we are able to benefit from speakers and panellists from both the Asian dimension and Africa. And I think you'll find that diversity very helpful in terms of sharing learning and experiences. Before I introduce people, I just want to flag up that those who are listening are welcome to submit questions, comments, to introduce themselves in the chat. Tell us who you are, give your contact details. Generally, people find it helpful to know who else is out there, and potentially you can make new connections and start new collaborations around this theme. So do use that, and we will come back to that if time allows for some Q&A at the end. But I want to give the floor to three very eminent and experienced speakers who I'm really excited to hear from. Our first speaker is Ms. Reena Suri, who is the Executive Director at the India Smart Grid Forum, which is a think tank of global repute on energy transition, electric mobility and grid modernization in India. At ISGF, she has been leading research, advisory services, capacity building, member relations and outreach, and business development since 2013. She has over 15 years of experience in the energy sector and has played a pivotal role in shaping smart grid and electric mobility initiatives in India and the wider region. Prior to ISGF, she worked with a variety of international organizations, contributing, for example, to USAID-funded power sector reform and smart grid projects across India. So, Ms. Suri, very pleased to see you again and to hear your comments. What we've set out is a sort of broad landscape of information and information gaps. So from your point of view, drawing on the work that you do at ISGF with utilities and distribution companies, how do you see electric cooking impacting household load profiles? And what are the key considerations for DISCOMs in planning and managing the additional load from large-scale adoption of e-cooking? Over to you, Ms. Suri.
Thank you so much. I hope I'm audible. Am I audible?
Yes, yes.
Okay, great. Thank you, Dr. Nick, for the question and for MECS and the country partners, Finovista and also Gamos East Africa for this opportunity to talk as part of this series and which is bringing together a very critical and a very important discussion which we have been talking with many stakeholders, not only to grapple with the kind of new loads getting connected and of course how electric cooking evolving in the energy landscape is going to bring the changes and what upgrades required. So from the perspective of India Smart Grid Forum, we see electric cooking, it is a very relevant topic today because it reflects how the household electricity demand is evolving and what this means for the distribution utilities and, overall grid planning and how the renewable energy integration. So this is another piece that I wanted to bring into this discussion. And we have, if you look at electric cooking, at the household level, appliances such as the induction cook stoves, electric pressure cookers, and they typically draw between 1 and 2 kilowatts. And the key issue with discoms is not the total energy consumed. I feel that over the day, but the coincidence of cooking loads during morning and evening peak hours when the networks are already stressed during light, due to lighting, cooling, and other household loads. That are plugged, and this challenge varies, of course, varies from rural, peri-urban, as Mr. Sinha has also mentioned, and urban areas. It also, depending on the appliance ownership of and capacity of the people, the diversity factor, and the strength of the local infrastructure. Again, it varies from that. Now, this makes it very essential for utilities to treat electric cooking as a part of the long-term demand planning and rather than just as a marginal or isolated load. And discoms need more understanding of how the cooking demand and interacts with other rapidly growing, like we have seen a huge influx of electric mobility and space cooling and digital infrastructure getting added and demanding energy, and how these combined demands impact the feeders and distribution transformers. I'm sure we'll be hearing more from Pramod, Mr. Pramod also on this. What I wanted to reflect here is, at the same time when electric cooking is adding to the load, and discoms need to do their load planning better. But electric cooking is also, is also presently providing a significant opportunity for utilities, particularly in the regions where, with high penetration of rooftop solar PV. And many discoms today, they are facing operational challenges with such as over voltage, inverter tripping, and voltage fluctuations during the peak solar generation hours. So this reflects, this overall results in curtailment, underutilization of the locally generated renewables, which is neither economically or environmentally optimal. So to mitigate, that some of the discoms have even gone ahead and requested the regulators or are ready to provide free electricity during the solar hours, and which is a time when their utilization curve is low, which also has been reflected in the previous presentation by Mr. Nigel. And these are particularly very concentrated pockets, like in India we have states like Gujarat, Kerala, and Rajasthan, where there are high concentration pockets, and utilities are really grappling with that. And so thus going forward, electric cooking, it can be repositioned as a grid supportive and flexible load. And cooking demand, it can be shifted, especially for appliances like induction cook stove and the electric cookers, to a daytime hours when the solar generation is at peak. And this surplus rooftop solar energy, it can be used locally, reducing all the problems that the discoms are having. And to actually explore this opportunity and the concept, ISGF, worked with one of the utilities in Gujarat with for a proof of concept, where we selected 10-15 households on 2 feeders with high concentration of rooftop solar. systems, and these households were provided induction cook stoves to demonstrate this proof of concept. The aim was to showcase how the well-timed cooking loads can improve solar self-consumption for consumers while easing operational stress for the discoms. And these kind of real world pilots we feel are very critical for building an evidence and confidence among the discoms and further taking it to the policy makers. And also I want to highlight with this kind of experiment, and we going forward, we have seen a lot of these smart home AI based smart home solutions and smart appliances that hold the future for a smart home. A key enabler for scaling electric cooking in a grid-friendly manner and enabling the DISCOP to manage the load, these are going to play a very key role. And with the smart cooking appliances, when integrated with the home energy management systems, they can automatically optimize their operations based on multiple factors such as time of day tariffs, rooftop solar availability, and household load limits that have been sanctioned, and even the utility signals. So for consumers, this translates into lower electricity bills, better utilization of rooftop solar, and improved convenience, and also without compromising their own cooking needs going forward. And for utilities, these AI-enabled homes will provide more predictable and manageable demand, reduce peak load stress, and improve visibility at the last mile, and also in some cases with defer the infrastructure upgrades required for the peak demand management. And when we combine it with the smart meters and the advanced metering infrastructure, the utilities can use this analytics and AI to forecast the cooking related loads more accurately, identify stressed feeders in advance, and design targeted demand response programs also going forward. And lastly, just highlighting, from a policy and regulatory standpoint, electric cooking, it should therefore be promoted not just as a clean cooking option, but as a part of a broader demand side management and digitalization strategy, with time of day tariff and incentives for energy efficient and smart cooking appliances, and also utility-led pilot programs. They can significantly, help shaping consumer behavior and ensuring system readiness. So finally, in conclusion, I would say that ISGF's perspective is that the electric cooking should not be seen as a burden on the grid, but this with the right planning and frameworks and digital tools and policy support, it can become a valuable flexible resource, helping the discoms manage their peak demand, improve renewable energy integration, and also deliver a cleaner and more reliable and more efficient power systems and cleaner way of cooking for the consumers. I think that's all from my side for now. Thank you.
Thank you, Ms. Suri. That's a great, very positive message, which we 100% endorse. I think MECS is founded on the observation that providing people with the ability to cook with electricity can really support the generation and the access to electricity, which hopefully will transform so many people's lives across the global south, both in terms of cooking and other areas of their lives. So yeah, no, but I think also your presentation, your talk has showed how complex this landscape is, the number of different components that need to be kind of considered together, and the critical and central role of discoms in India and utilities in other countries as well. And I think that another point I just want to draw out is that we're seeing a lot of interest in a number of states in starting an e-cooking transition amongst the institutional and commercial sectors, where there is the bulk of the cooking carried out during the daytime rather than in the morning and the evening, because they want to maximize that income generation without adding to the peak load demand that they're going to face. And I think that's another quite strategic way to handle all this. Okay, and I should say that your comment also about combining with the solar rooftop program also is something that we're seeing a lot of interest in, and working with the government of India to going forward on that. Okay, our next panelist is Dr. Engineer Fenwicks Musonye. Hope I pronounced that right. He is a Director, Deputy Director of Energy Efficiency at the Energy and Petroleum Regulatory Authority, or EPRA, which is Kenya's independent energy sector regulator, responsible for technical and economic oversight of electricity, petroleum and renewable energy. Dr. Musonye holds a BSc degree in mechanical engineering from the University of Nairobi, an MSc and PhD degrees in energy technology from JKUAT, and a postgraduate diploma in project management from KIM. As well as his role at EPRA, he also works for Strathmore University and the Africa School of Regulation. His areas of expertise include energy auditing, energy management systems, appliance standards and labelling, curriculum development, and many other areas. So I'm very interested to hear your remarks, Dr. Musonye. I hope you're able to turn the camera on so we can see you and hear you. I guess the question that I would have for you is, how are you seeing the adoption of electric cooking affecting energy demand in Kenya? What measures are you putting in place as a regulator to encourage and support utilities to respond to and prepare for these changes? And I should just, while Dr. Musonye hopefully is becoming available, just to flag up again in the chat, there are a number of questions coming up. There's also a lot of AI bots appearing, but people also introducing themselves and starting to form little coalitions. So I encourage you again to use the chat. Dr. Musonye, yes, hello.
I can hear you. Hello, Dr. Rousseau. Thank you very much for the question about clean cooking, especially electric cooking in the country, which has been quite a new concept, which is actually being spearheaded partly by the utility Kenya Power and Lighting Company. They have what you call Pick and Power program, where they're encouraging people to take up the e-cooking devices. However, of course, this comes with a number of issues that were initially presented here, actually about the dark curve. The dark curve is having issues with everyone in parts of the global south, where mostly people cook in the evening hours, and you find the demand has gone quite high. Of course, there are a number of interventions that we need to do to increase the uptake of clean cooking in Kenya. One is the concept of the cost, because people think it is still expensive to cook using electricity. There's quite some amount of work we need to do there to try to demonstrate that substituting the traditional cooking methods with the e-cooking is actually a cheaper option. Of course, alongside other issues of indoor air pollution, the issues of safety and everything, which we are really doing. We have developed actually the e-cooking guideline. I was the team leader for that, and it's published online to try to assist the citizens to adopt that. But then that's on the issue of the market penetration. When you look at the demand side, which I'll actually dwell a very short time discussing, I will specifically focus on energy efficiency, where I'm an expert, because that's the one that's going to assist us in two ways. One, in reducing the cost of cooking so that it can assist us to improve the narrative that clean cooking or e-cooking is indeed affordable compared to the traditional cooking methods. Then to assist us in number two, in managing the load, the demand from the side. And actually, we talk about virtual power plants. And I'm happy most of the participants here, I see some are from India. India is doing very well in terms of standards and labeling. And that's why I want to really focus on, because we've been borrowing a number of things from India. We started standards and labeling in Kenya, but we're looking at cooling appliances initially. That was the refrigerator and the air conditioner, and then the motors and lighting. By then, cooking using electricity was not a thing in the country, because that was in 2013. But now, because it's a thing, now we are thinking of increasing the number of appliances under MECS. But then, of course, there comes the problems. There are things we are supposed to do from the Kenyan side. And I hope, of course, we learn from the Indian experience and the Ghanaian experience. Ghana has also a number of appliances that are under the standards and labeling. That's the MEPS. So we need to develop minimum energy performance standards for the cooking appliances. this will assist us a lot in ensuring that we lock out those appliances that are not efficient. Because I always tell people that e-cooking does not necessarily mean efficient cooking. The E is electrical, but not efficient. So for us to go to efficient, then we need to do the standards and labeling. We are, first of all, planning to collect data, because for you to make any standards, then you label, then you must do it based on what is already in the market. So we hope to collect the data for the performance of the appliances already in the market. After we collect this data, we're going to segregate it. Actually, mostly we use an ogive to see which percentage of the appliances are in which category of the efficiency. Because once we get that data, we will now come up with the cutoff point in terms of the performance, and say if we have any appliance that's not performing above these, we'll use primary data that's already in the country, then we are knocking you out. So by so doing, we are going to now know that we will knock out a number of appliances that are already in the country, but they are contributing badly to the demand, the grid demand. So after we've done that, of course, we'll now develop the standards based on what we have. We've done the cutoff. Then we develop the performance itself, and then develop the labeling. And the good thing with the Kenyan market is that we already have a platform and a framework of enforcing the MECS, standards and labeling. So we will just incorporate the standards into the existing regulations, because we have the standards and of the regulations. So we will incorporate the standards into the existing regulations, then we'll pick from there. And how are we doing this? We are almost revising our regulations for standards and labeling. The regulations were published in 2016. So by next year, we're supposed to start revising them, and we will now introduce to the consumers this concept of having standards for e-cooking appliances. Now, we have two options. I know India starts with the voluntary, then goes to mandatory. Now, in Kenya, it's very difficult to change the market. Once you make something voluntary, you will not make it mandatory. You will be subject to courts, litigations and everything. So what we're planning to do is to just start with it, specifically saying that when we roll it out, we roll them out as mandatory standards. And we have a justification for that, because the country has a problem with load shedding right now. We're doing load shedding in some areas. And then number two, we have problems of voltage stability in some parts of the country, like in Western. So in that area, if we have more e-cooking appliances there, the problems, the way they are without being efficient, then the problems of grid stability are going to be increased. So for us to spread these e-cooking appliances beyond Nairobi and the Nakuru, these urban centers and Mombasa, to go to the villages, then we will need to have the MECS, and that issue of the grid or the power quality and the issue of the load shedding will be used as one of the examples, one of the reasons why we need to have the MECS for e-cooking appliances. Of course, then just to conclude, we might think of other issues which I'm not an expert in, like the battery storage. I think that could also be very useful in some areas where we could be increasing or taking up the power during the day when the consumption is low. Then we release the power in the evening hours to try to deal with the e-cooking thing and the lighting issues and the TV watching at the evening times. Otherwise, thank you very much, Dr. Rousseau. Those are my submissions for now. Thank you.
Great, thank you very much. Very clear presentation, and good to reflect on the impact of energy efficiency or potentially inefficiency in electric cooking appliances. As you say, there are historically many devices which are extremely inefficient and very wasteful, and a lot of our research has focused on the opportunities that these new, more efficient appliances can offer, such as electric pressure cookers, and particularly in Indian contexts where induction and infrared devices are now increasingly prevalent. And the sharing of good practice in terms of standards and labeling, I think, is really encouraging as well. I'm glad to hear that you're drawing on India's experience, and we work closely with the Bureau of Energy Efficiency, which is responsible for the star labeling program in India, which now includes induction stoves, And we expect from early next year that will become mandatory, so that all induction stoves in the Indian market will have been approved under that program. We would love to see a greater range of devices tested and proven, because there is, yes, electric cooking, unlike electric light bulbs or maybe air conditioning, is such a diverse sector. There's a real need to find a kind of way to test the energy efficiency of appliances across a great range of different types. So it's an important and challenging area. Again, just to flag the chats, there are some questions popping up, so do add your questions, introduce yourself. I'm trying to make a note of the questions as we go, coming in from different countries. Okay, our next panelist, I know is a supporter of electric cooking also. He is Mr. Pramod Kumar Mishra, who's the Vice President and Chief Transformation Officer at Chandigarh Power Distribution Limited, which is the designated utility responsible for electricity distribution and retail supply in the Union Territory of Chandigarh in India. He leads key initiatives to modernize power distribution operation and enhance organizational performance. And he is a seasoned power sector leader and transformation specialist with over 2 decades of experience driving operational excellence, strategic initiatives, and business transformation. And before his current role, Pramod held the senior leadership positions at BSES, where I think we first met him. So great to meet you again. His work has included leading distribution network planning, performance optimization programs, and complex transformation projects within the utility sector. So it sounds like the right person to be talking to here. Pramod holds a Bachelor of Technology in Electrical Engineering from IIT Roorkee and has pursued advanced leadership education through an executive program at Georgetown University. So, Mr. Mishra, at the Chandigarh utility, the Discom there, what is your thinking about electric cooking? Do you see it as a problem or as something to embrace? And how are you going to be preparing for the future in this regard? Over to you.
Thank you, Nick, for that very good introduction. And the panelists have also already set the context. Being the utility person, I would say that this is more than opportunity than a challenge. And wherever opportunity is there, utility is always to embrace it. You see, people generally feel that utilities, it will be difficult for utility to manage any big load like electric cooking. But if you see on the ground, utility is facing challenge of load growth, especially the urban utilities. You have the high growth in some of the sectors or some of the areas, but in the most of the part of the country, the load growth is very low. When I say load growth, it is like energy growth. So energy growth is very low, and load factor, if you see in most of the cities, it is less than 0.5. So network utilization is a challenge. We, as a planner, invest in network, but the load is only for some duration. It is not for larger duration. So energy consumption is low. Now with the electric cooking, or if we add the EV part also, these are the two load which is coming up in a big way. In most of the Indian cities, the electric vehicle is now picking up, and so is the induction cooking. We at Chandigarh Power Distribution Limited, we see that there is big case for electric cooking in urban cities, especially in case of Chandigarh, wherein the customer are generally middle class or higher middle class and have the higher cooking load. And the best part with this cooking load, it is like complementing load. This load is the timing of such e-cooking load is likely to be different than the air conditioning load. So air conditioning load generally starts at 8 p.m. in the evening, whereas the cooking load ends by then. So general trend is like first you cook, then you eat, and then you go to your bedrooms when the AC load picks up. So the e-cooking load is like opportunity for Discom. Obviously, you have to tweaking your network at different points because you don't have the base of e-cooking load. You have to estimate it, correct it, and then based on the corrected plan, you have to plan the network. Generally, as a planner, we plan 2.2 times of the load so that there is sufficient redundancy in case of outages. At 11 kV level, we have planned, and most of the case it is getting executed, the ringman system. So if the one source fails, the another source power can be switched on to another source, because for electric cooking, the reliability of power can be the major concern. If a person is cooking and there is outage, and then it is very difficult situation for the households. Fortunately, in India, especially in the cities, urban population, the reliability of power has improved over the last few years, and it is nearly 24 hours. So with this kind of reliable power and robust network having N-1 reliability, the serving the induction cooking is quite possible. And generally, based on our assessment, the induction cooking load is of the order of 15 to 20% of the existing load. It has potential, and network generally have this kind of margin. Overall network have the margin built in, and wherever the requirement is there, it can be progressively done at low voltage, high voltage, and extra high voltage level. Another thing I wanted to point here is that being utility, we want to utilize the network at fullest, because the capital investment is generally planned for the peak network, peak load, and the utilization is low of the order of 46-47% in our case on most of the urban cities. So with these kind of load and the load in the valley, in valley part of the duck curve, so if we get similar such kind of e-cooking load, this is going to boost the revenue of the utility, and this is actually going to support the utility business. Uh, Another part is like before going to this electric cooking, because the load is going to be significantly high of the order of 2 kilowatt in general. The wiring of the house need to be checked before putting electric load into picture. Uh, Generally, the houses have the old wiring of the 15, 20, 30 years old. And if we connect a similar kind of, such kind of bigger load, then it is advisable that we should get the wiring checked on. If required, the higher size of wiring should be done before going for the such kind of e-cooking or bigger load, or uh, even for that matter, e-vehicle load. Smart meter is also coming up big way, and it is picking the pace in Indian cities. So with the smart meter in place, people have higher access or higher control to their load. They will be able to understand the load pattern, and the TOD is also coming up. Different regulators have come up with the TOD mechanism. In some cases, domestic also, but in most of the cases, commercial and industrial. So that TOD with a smart meter can be facilitator for e-cooking. Uh, One of the major factor of adoption of e-cooking could be the lower tariff, as some of the participants have also put on question regarding the tariff and the subsidy. So, city like Chandigarh have very efficient tariff for domestic consumers, and it is much cheaper. So that makes a big case for electric cooking in city like Chandigarh. We have capacity in the network. We have power tied up for meeting the load of the eCooking or e-vehicles. We have cheaper tariffs, so all set to welcome the e-cooking in city of Chandigarh, and we see e-cooking as opportunity for us as a utility, not threat. And we are also gearing up to prepare ourselves. We have done something. We are in the process of upgrading our network to provide reliable and cheaper supply to our customer, including the e-cooking load. So I'll pause here and over to you, Nick, for now.
Thank you very much, Mr. Mishra. That's great. I'm conscious of time, so I know some people will be leaving this chat, this webinar, but I'm happy to continue if colleagues are, just for a few more minutes, because we do have some questions coming through, as you rightly acknowledged. But yeah, no, you're right, and I think the point about the wiring and the kind of infrastructure more broadly is really critical here, as well as the kind of generation capacity and ability to provide the electricity. There's that route, there's sort of what do you call it, all the way down to the household kitchen, which can be a challenge. And we've got a number of questions, in fact, that have come up. So maybe you could respond to those from the point of view of your own experience, but others may also come in. So there are three questions which, in my simple understanding of these things, are kind of related. So one is, how many electric cooking households can be added to a low voltage line? I'm not sure how low a low voltage line is before the voltage drops are exceeded, when it becomes essentially overloaded. And the comment is from, I think, Stuart Crane, who's in Kenya. We've used 1 kilovolt transformers as a solution for this, which can increase the load carrying capacity by 2.5 up to 4 times. So that was a particular question about sort of the capacity to carry additional cooking loads. And then a similar question, any estimation or studies on how many electric induction stoves on regular usage can be connected to a local distribution transformer before it requires an upgrade? And do residential wiring of certain capacity rating need upgrading, especially in rural India, with households of rated power of 1 kilowatt, in order to prevent kind of overheating? So there's a number of related questions, aren't there, about how to approach that question of the households and the communities where there is maybe a lower level of infrastructure already in place. Would you like to respond to that from your point of view, Mr. Mishra?
Yeah, thank you. You see, if we address to the question regarding how many appliances can be added to a transformer before upgradation, so it depends the existing size of the transformer. Good thing with the induction kind of cooking, as we have seen the presentation, that it has very low diversity, like 10% in some countries, some 12%, 13%. So with the low diversity, you can connect more devices. And it all depends on the capacity. Generally, transformers are designed for overloading for a few hours. So those can be even overloaded. That will be the optimal utilization of those transformers. So that is not a problem. And in case if it require, augmentation to higher size, utility will be loved to do that, because there is business there, that there is potential consumption of energy. So that is not a problem.
Okay. Sorry, I don't want to cut you off. I'm conscious that Reena's also come on, so she may want to add to your comments, but carry on. Would you like to carry on, Mr. Mishra? Sorry.
No, I have finished one part. And what was the second part of the question?
It was a similar question. Like I say, in my simplistic understanding, a similar question about how many stoves can be used, and also what kind of wiring capacity is needed, and how and when do you kind of decide to upgrade it?
Yeah, so you see, the wiring in rural India or any house, it is generally of lower than the required size, because people generally have the present load in mind while wiring or while developing the wiring of any house. So when you enhance the load, then it is required that the wiring should commensurate with that. Yes, in rural India, you have generally 1 kilowatt load and wiring is according to that. But for induction cooking, you have to upgrade the wiring to the next level and requisite size. Yeah.
Okay. All right. Well, thank you for that. I think this is as I say, it's opening up a new area. Well, not new for us, but a new dialogue, if you like. Reena, would you like to add your comments?
No, I think thank you. I think Mr. Mishra has rightly covered the first two questions which were posed, that in terms of the load by cooking appliances, as I also mentioned, that currently we have seen the uptake of primarily electric induction cook stove, and which is 1 to 2 kilowatt, and I'm sure the current feeder load can manage that very well. In terms of we don't see any fixed number of electric cooking per household that in that area needs to be a worry at the low voltage line before the voltage limits are breached. So that is not a constraint, as Mr. Mishra has also confirmed that. But there was another question around, if there is a subsidy provision in electricity to lower income people. I can just quickly address that. In India, the electricity subsidies to the low income households, they're generally provided, as subsidized tariff slabs, and where a certain number of units per month or are either free or charged at a highly concessional rate. And while these subsidies, they are not always very explicitly linked to electric cooking, but they are indirectly supporting the adoption of cooking in most those low income groups, and also in the rural side. And we see that these can include electric cooking is to be promoted, to promote it more to the low income households, and also targeted approaches are needed for an effective broad subsidies needs to be brought in, and these could include lifeline tariffs aligned with essential energy needs, which are supported for energy efficient cooking appliances. And also a careful look at the tariff design needs to be done to ensure affordability without creating an excessive stress for the utility finances. So yes, subsidies, but it should not stress, not in terms of finances for the utilities as well.
Thank you. And one thing just to add to that, and we've seen two types of those lifeline tariffs. One is where up to 100 units, the price is essentially free, which is great, or very, very low. But then once you get to 101, that the next band up are at a higher tariff, which is what I'd expect. But I've also